All right, in this Big Ideas Algebra 2 tutorial, we're going to finish up the second section of 3.1. We're going to focus on solving quadratic equations algebraically. So there's your learning objectives, solving quadratics algebraically. So the first probably method you should always be checking whenever you're solving algebraically is to just use your reverse PEMDAS to get your x by itself. So PEMDAS forwards is how you combine like terms. PEMDAS backwards is how you solve and isolate your variable. So for part A, we have 4x squared minus 31 equals 49. First thing we're going to do is add the 31 to both sides to get 80. That 4 is being multiplied to the x squared, so we're going to divide both sides by 4 to get 20. And then the last thing we do is get rid of our exponent. The opposite of squaring a term is square rooting. And remember, earlier we talked about that whenever you take the square root of a number, you have both the possibility of getting a positive and a negative number. And we're going to start reducing our terms and keeping them inside the radical. So whenever you're reducing numbers inside of your square root symbol, you need to find a number that is being multiplied where one of them is a perfect square. 4 is a perfect square because you can take the square root of that number and get a whole number. So we're splitting 20 up into a product of 4 and 5 so that we can better simplify and get that 4 to turn into a 2. That 5 stays the same way because it is not a perfect square and there are no more perfect square factors of that 5. If you need to look at a list of perfect square numbers, I recommend that you get familiar all the way up from 1 through 12. So that would be 4, 9, 16, 25, continuing all the way up. So imagine if you take a number and square it, that number is a perfect square. You could also be writing it with the plus minus sign in front, or you can separate it and write it as 2 radical 5 or negative 2 radical 5. So looking at the second one, again, we're going to do reverse PEMDAS. We're going to get rid of this positive 9 out in front by subtracting. We're going to get rid of that 3 out in front by dividing. We have x squared is equal to negative 3. Notice how the last thing we have to do is take the square root of both sides. Well, you cannot take the square root of a negative number, so this equation has no real solution. In the last lesson, we talked about the possible number of solutions. You could have a quadratic that crosses the graph twice, crosses the graph once, or crosses the graph 0 times. This equation, part B right here, is an example of a quadratic equation that never crosses the x-axis. There are no numbers, there are no point in this graph does it cross the x-axis, so it has no real solution. We'll talk about some unreal solutions later, but just for right now, no real solution. Last one, we're going to work with everything outside of your parentheses first. So we have 2/5 times that parentheses. The opposite is to multiply by the reciprocal. So we're going to multiply both sides by 5 over 2. 5 times 5 is 25, and then that 2 is on the bottom. Then we have an exponent outside of our parentheses, so we can then square root both sides to get rid of that exponent. So you take the square root of 25 over 2. Again, always making sure you have your plus or minus in front. And then we're going to subtract 3 on both sides to get that x by itself. Now, in order to help simplify everything inside of the square root, you already have a perfect square in 25, but that radical down there on the 2 is something that we need to take care of. That is not a real solution if you leave your radical in the denominator. So you need to make sure that you are multiplying by whatever it is on the bottom to the top and the bottom by itself. This is what's called the conjugate, multiplying by the conjugate, taking whatever's on the bottom, multiplying by radical 2 over radical 2. This is the same thing as multiplying by the whole number 1, so it does not actually change the equation, it just rewrites it in the correct form so that you don't have a square root symbol in the bottom. You may hear some instructors say, don't go around with your radical down. That's a good way to remember that your final answers cannot have radicals in the denominator. And then when you get this 25 square root to be 5, you're multiplying by 2. Radicals on top are okay, but radicals on the bottom, it just becomes that whole number. Because radical 2 times radical 2 is radical 4, and the square root of 4 is 2. When you multiply something by itself, you're squaring it, so you create a situation where there is a perfect square in the denominator, and then you get that whole number after you take the square root on the bottom. And again, you can write that as plus or minus if you separate it, or you can write it as plus or minus together. All right, so now using by factoring. This is the method we're going to use whenever you cannot use PEMDAS to get an x by itself because there are multiple x's. In the previous problem, there was only one x squared term listed. There was not an x. It was easy for us to use PEMDAS. And if we go back to even the ones before, notice how you're just looking at a single x term. But now we are given multiple x terms, so we're going to have to end up trying factoring. So first thing you need to do in order to factor is to move everything over to one side and set it equal to 0. Standard form, ax squared plus bx equals c. So you got a positive 45, subtract it on both sides, just move it, and it has to set equal to 0. The next thing that we're going to do is factor. There's a lot of things that are happening here, but what you are trying to do is find two numbers that multiply to equal negative 45, but add to equal negative 4. So a lot of these are going to have to be kind of guessing and checking. I think during in Algebra 1, you were introduced to how to factor quadratics. If you do need a little bit of review, I'm sure there are other videos that are out there. But again, your goal is to look at numbers that multiply to equal your C, but add to equal your B. So if it helps you to write out a T-chart of numbers that multiply to equal 45. So you go 1 times 45, 3 times 15, 5 times 9, and just keep writing all of them out. See which one of your pairs add to equal that negative 4, looking at both positive and negative factors. So for this set of numbers, negative 9 times positive 5 equals negative 45. Negative 9 plus 5 equals negative 4. Whenever two things get multiplied and they equal 0, you can assume that one of them has to equal 0 because you cannot multiply something to get 0 unless one of them is 0. So you're going to separate them, and this is creating a situation where you have a quadratic that crosses twice, so you're getting two solutions. And then from here, you just do PEMDAS, add 9 both sides, subtract 9 to get x equals 9 and x equals negative 5. And again, that talks a little bit more in detail of finding the 0 of where that graph crosses the x-axis, where your x value equals 0. All right, so we're going to find the zeros of quadratic equations where your a is not 1. It is a bigger number than that. So again, to find the zeros where your x values, for which you have to set it equal to 0. That's why it's called the 0. Then in order to factor this one, you're going to be multiplying 2 times your 12 to find your factor number. So this is your multiplying 2 times 12 to get 24. Then you're finding factors that multiply to equal 24, but add to equal negative 11. So those two factors are going to be 24 to get negative 11 are negative 8 and negative 3. And then you have to make sure that you are dividing that 2 back out after that. So this is where you had your 2 times your 8, and then you're going to factor that 2 back out in front to simplify down to get to that negative 8. I can also post some other videos that help with factoring equations that your a is greater than 1. But again, this is something that should have gone over in Algebra 1. We're going to continue practicing this week. So then you separate those two and solve. Add 3 to both sides, add 4 to both sides, divide by 2. You can either write it as 1/2 or you can write it as 3 over 2. And those are your two zeros, or your x-intercepts of that graph. You can always check it by plugging it in the graphing calculator. And wherever that graph crosses the x-axis is one of your zeros.